Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on the Number Theory and Abstract Algebra chapter, and this is the 17th question. Here we're given three rings, and we are asked which one or ones are integral domains. So I'll just remind you that in order for a ring to be an integral domain, it has to have a unity, and it has to have no zero divisors. What does that mean? Zero divisors means that if two elements multiplied by each other equals 0, and neither of them neither of them equals 0, then we say that the ring has zero divisors. Okay, so if the product implies that one of them equals 0, then there are no zero divisors, and it is an integral domain. So let's see, z plus z, the direct sum of the integers with the integers, is that an integral domain? Well, let's think about it. If we have the element 0, 1, and we multiply it by the element 1, 0, clearly neither of these is 0, but their product is 0, 0, which is the 0 in this ring. So the direct sum of z and z cannot be an integral domain because we have zero divisors. So this does not work. 2, zp, where p is a prime. This actually is an integral domain because it's also a field, and any field is also an integral domain. A field is like an integral domain with more criteria, but yeah, because it has inverses. But zp is definitely an integral domain. So 2 is an integral domain, and 3, zp squared, where p is a prime. This will not be an integral domain because, if we take, for example, let's say p equals 2, then if we look at z4, this would be zp squared, then we can see that 2 times 2 is equal to 0, and neither 2 and 2, neither of them is 0, so this would not work. So our answer is 2 only.